Alrighty, so now let's talk about percentiles and z-scores. And this is actually going to build off of the ideas that we had in the first half of the unit. And specifically, within each data set, each observation has a specific location. As of now, we use the quartiles to help us describe the data in these 25% sections, meaning that Q1 is the 25th percentile, Q2 is the 50th percentile, and Q3 is the 75th percentile. And this is because 75% of the data or less occurs at Q3. 50% of the data or less occurs at Q2, and the same idea for Q1. In reality, it is not very likely to have an observation that we would conveniently fall at one of these percentiles. Thus, we use percentiles to describe the percent of values or less than this particular value. If a particular value is repeated, we're going to use the last value as our cutoff for this percentile. So one percentile that you might all be familiar with is your percentile rank relative to your class. You know, this top 10%, bottom 10%, etc. So just, it helps us to describe this location in relation to the entirety of the data set. So this isn't an official formula, it's just more of an idea. But basically, this helps us to find the locations. Very similar to the quartiles, they'll tell us what percent of the data happens there, but also where it's located. So we interpret a percentile as the following. The value of P occurs at the blank percentile, which means this percent of context occurs at or below blah, 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 blah. Again, a bunch of hoopla until we actually look at an example. So I is going to be the observation. So I is your observation, N is your sample size, and P is going to be the percentile that you want. And so remember, this is going to tell us where it's located, not what the value of the percentile is. So let's take a look at an example here. And the scores obtained on the AP Lit exam were as follows, blah, 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 blah. And you can see here, it's nice and organized. This might not always be the case, so you might have to make a dot plot or something, but it'll help you to organize where your data falls. So what score falls at the 25th percentile? Well, let's take a look here. Let's count them up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Excellent. Okay, so with this though, remember when we looked at our 5-num sum, we were looking at specific like n plus 1, and then we were looking at the medium, etc., median, which was the middle. But for this idea here, we can actually just find its position by multiplication. So for example, since I want the 25th percentile, I is going to occur here, so 25 out of 100 times our sample size, so 0.25 of 20, it's going to give me 5. So my percentile is 5. No, it's going to happen at the 5th observation. So I'm going to count over 1, 2, 3, 4, 5. So a score of 72 or less represents the 25th percentile. 25% of people in the sample had this score on the exam or less. So here, a score of 72 points. All right, find and interpret the 50th percentile. We're going to do this kind of mumbo-jumbo magic again. So here, I want the 50th percentile out of our data set. So we want now the 10th observation. Well, here's 5, 6, 7, 8, 9, 10. Okay, so now here's kind of Q2. Remember, we would do n plus 1 divided by 2. So really, the median is at about 84.5, but percentiles we're just roughly approximating. And we're going to use more with percentiles in terms of the normal distribution. This just happens to fall in the AP exam every now and again in maybe a multiple choice section. So here, I'm going to interpret it using our sentence stem from above. So I'm going to say, a score of 84 points occurs at, does my O just not want to work? A score of 84 points occurs at the 50th percentile, which means 50% of the test scores occur at or below a score of 84 points. Cool beans. So you can see we just locate it and then we interpret it. Nothing too spicy here. Which score represents the 75th percentile? All right, 75 out of 100. That's going to be 0.75. So 0.75 times 20. I'm going to need the 15th observation. And so here, 10, 11, 12, 13, 14, 15, here we are. All right, so a score of 90 points is going to be the 75th percentile. All right, so go ahead and pause the video now and try the last two. Be careful with this one, the 90th percent. Oh, no, you don't even have to be careful with that. Dude, you're going to be all right, or dudette, or person. So here you go. Pause the video and go ahead and try to find these values and then come back and we'll review them together. And we're back. All right, so just checking to make sure that you were able to work these out. This one was a bit of a trick question because then it gave you the score and you had to just find that where it was located. It was located at the 12th position. Do some mumbo jumbo here. Occurs at the 60th percentile, meaning that a test score of 86 occurs at the 60th percentile, meaning 60% of people in the sample scored an 86 or lower. And then another formula question there, a score of 98 points would occur at the 90th percentile because you're better than 90% of the people. All right, now, since we are comparing the observations to the entirety of the data set, it would make the most sense to use the mean and the standard deviation. Now, in a few lessons back, we said that we only use these summary statistics if the data is approximately symmetric, because they would give us a better representation of the center and spread. However, since we're looking at the entire data set here, it doesn't really matter if our data set is skewed or symmetric, because both of these summary statistics are just going to tell us how the data is behaving. And so I'm just looking at the location relative to the mean. I'm specifically looking at how far away we are from the mean. So since these summary, and we do this because they take into account the entire sample n. We do this by computing the z-score, which tells us the amount of standard deviations from the mean. So a z-score will tell us the amount of standard deviations we are above or below. So we have two formulas here, and you do have to memorize this formula. This formula can be derived backwards, but if information about a population is known, we use this formula here, which says z equals the observation minus the population mean and the population standard deviation. But we don't always know information about the population. So in general, we'll use the observation minus the mean divided by the sample standard deviation. We're going to get more into mu and sigma a little bit later, but that's just a bit of a tease as to what's coming up. So x here is going to represent our observation. Mu is going to be the population mean. Sigma is the population standard deviation, and z will be your z-score. Now there are two ways to interpret it. If you get a positive z-score, this means an observation falls above the mean. And if you get a negative z-score, this means the observation falls below the mean. And if you get a z-score of 0, you are right at the mean. So I'm basically, once I have the average of my data set, I'm just checking, am I above average or below average or an extra average? So here we go. Let's take a look at this example and then you will do some on your own. So Mr. Pinto has 43 students in AP Stats and knows that there are 45 enrolled in AP Calc, AB, and BC. Mr. Pinto wants to compare how students are performing in AP Math classes, and Mr. Pinto has 10 students who are enrolled in both AP Stats and AP Calc. The first unit for AP Stats had a mean exam score of 75 with a standard deviation of 4, whereas the first unit exam for AP Calc had a mean of 80 with a standard deviation of 6.5. Find and interpret the z-score for a student who scored a 73 on the AP Stat exam. So I'm going to start off with my little formula here, and I'm going to just write down the formula that we are using. All right, so you can see observation minus mean over the standard deviation. So we got a 73 with a mean of 75 divided by 4. And that is going to give me a standard deviation or a z-score of negative 0.5. And we interpret it as this. And we don't really need, the sign is only going to tell us if we're above or below. So we're not going to say we're negative standard deviations away. We're just going to say above or below. So a test score of 73 points has a z-score of negative 0.50. Which means it falls, and again, I don't know why my O's don't want to work, which means it falls 0.5 standard deviations below the mean of the AP Stats scores of 75 points. below the mean of the AP Stat scores of 75 points. So that's it. You just do a cute little formula and write a cute little interpretation. So not too shabby, I hope. I feel like we can definitely do this. So let's do one more example, and then you'll try the last few on your own. So here, again, I want x minus the average over the standard deviation. So an 83 in AP Calc minus 80 divided by 6.5 is going to be roughly about 0.46. And so our interpretation is going to sound like so. But a test score of 83 points has a z-score of 0.46. Which means it falls 0.46 standard deviations above the mean AP Calculus exam score of 80 points. Boom. That's all you need to do. So you're going to find your z-scores and you are going to interpret them. So go ahead and pause the video and take a look here at these 4 example questions, and in true fashion, we will come back and address them together. So pause the video, use your notes, try your best. We'll be back here shortly. Alrighty, so hopefully not too challenging, but here I would take the z-score relation of both classes, and it looks as though he did at average, or they did at average for stats, and they were actually below average for calculus. So which exam did they perform better on? And I would say this person performed better on the AP statistics exam because they were at average, whereas for the calculus exam, they were below average. So we answered, we gave some context, and then we have some justification here. Now looking at the next example, like I said, mu and sigma, we're going to talk more about this in the next 2 lessons. So this is just a preview here, but we have a mean of 300 and a sigma of 20. So the formula is the same. Instead of writing out the sample mean and the sample standard deviation, I write the population mean and the population sigma. And I find a z-score of 0.10. And generally speaking, anytime your observation's above the mean, you should get a positive z-score. And if it's below the mean, you should get a negative z-score. So here I got a z-score of 0.1, which means that a score of 302 on the exam has a z-score of 0.1, which means the score falls 0.1 standard deviations above the mean exam score of 300 points. And then we would use our reverse formula here. I've got the mean, I've got the sigma, and I have a z-score, so I use this formula to find the observation. So an observation of 306.8 points falls 0.34 standard deviations above the mean. And then lastly, this idea of equivalent scores, this also shows up. So Aiden scored 50 on exam A. I computed his z-score. I was told that we want them to be equivalent. I have some statistics about exam B. And so to find the observation, I'm going to take the sample average of B plus the z-score and then times the standard deviation. Sorry, y'all, teachers make mistakes too. And then you can see my substitution here. So in order for Aiden to do equally well on exam B, he should score 400 points, and that'll put him at the same location as with exam A. So those are just a variety of questions you could see on the AP exam. Just this general notion here is that a percentile is where you fall, and it's the percentage of data at or below that point, whereas a z-score is telling us the location relative to the mean, whether we were above the mean or below the mean. And then, of course, the percentiles that we're already familiar with are Q1, Q2, Q3. So overall, just line up your data, find where you're at, find the percentage below. Or if you're looking for a z-score, take your observation minus the mean over the standard deviation, and that'll tell you where you fall in location to the mean. So that's going to conclude our lesson on percentiles and z-scores. And the next lesson, we'll introduce the normal model and start getting more into the normal distribution.